Well, good evening. Okay, welcome to Environmental Coffee
Hey.
House. Hi, Jen. Hi, everybody out there. It's really great
Hi.
to see you. We made it. We made it. My microphone arm fell over only 3 times because of the cat, but we made it. Yay!
Yay, team.
Yeah, yay team. How you doing,
That's
Jen?
right.
Oh,
I'm
we got a
here.
lot
I'm
of
doing good.
people.
How are you doing?
Oh, what a day.
We've
I
got
did
a
a lot of
good
running around.
show.
Yes,
Oh,
we do.
yeah.
Yes, we do.
We have a good show tonight, guys. We're getting back to our roots, and you know what that is. It's time for
Mhm.
Tales of the Arctic. So we're actually going to tell kind of a story today. Right, Sandy?
Yeah. Yeah, we are.
Yeah.
Yeah, we are.
And it's
A
all
little
going to
bit.
tie together. So the first one is what happened to autumn? Scientists point to climate change. So this is kind of like a little Sherlock Holmes mystery
Uh-huh.
story, right? What happened to autumn? Climate change. And then the next clue is a warmer Arctic Ocean leads to more snowfall further south, according to a new model. And then we are going to take a look at what happened last January, which is actually pretty critical.
Mhm.
Strongest Arctic cyclone on record led to surprising loss of sea
Oh,
ice. You
yeah.
put all this together, and what do you got? You got a freaking methane emergency. So then we're
Wake
going to take a look at a
up.
post from Peter Carter. Methane emergency, big increase in atmospheric methane from powerful feedback.
Oh,
So
boy.
is it a quinky dinky
We'll
or is it
see.
cause and effect?
You're going to talk about that.
And we're going to take another. And then we're going to talk about another post from Peter Carter. He's been very active. World energy combustion, 89.8% CO2 emitting. What's all this? Yeah, I'm not sure. So this is zero carbon combustion CO2 atmospheric lifetime makes that certain fossil fuel CO2 emissions increasing fast. Oh my God, this
Peter?
is such a lot of gobbledygook. Well, we're going to
Well,
dive
yeah.
into it. All
Well,
right.
yeah.
Yeah,
We'll
I am
look at
not
his
sure. You might have to
graphs.
help me on that one.
We'll look at Peter's graphs.
Yeah, yeah,
Peter's style is a
yeah,
little
yeah,
different than ours,
yeah,
and
yeah.
we'll go through it. Yeah. And then we're going to look at the Polarstern. A little bit
Hmm.
of that.
That's
Oh yeah.
right. That's right.
Busy show. So how's everybody well, I'm
Yeah,
sure do you
we're
want to finish
close
up?
for it. And
We
then
have a little weird
greenhouse.
internet.
Yeah. Do we? Oh, okay.
Yeah, but it'll
Then
get better.
greenhouse gas emissions from Energy Data Explorer. Okay. And then we've got one from the Barents Observer.
Mm.
Meltdown of the Arctic Ocean, dead end or new opportunities. And
Yeah. We
is
get to
that
show
pretty
these
much
little
it, Sandy?
Yeah, we
Is
get to
there
show
is there
these little guys.
is there one from the Arctic?
We
Is there
may
one from the
do
Arctic Institute?
Yeah, we may do there's a couple of things we might do at the end. We may show you let's time, we may show you the executive summary of the Department of Energy's Arctic plan. We may show you an
Okay.
article from the EU. So we're gonna see how this goes and
Yeah, yeah.
and because we
We'll
have a
we'll
lot.
just see how long it takes us. We'll just
Yeah.
kinda
Yeah.
we'll be
And then
agile in our
uh,
approach, guys.
yeah, agile. And we have a tiny little intermission, this tiny little cute
Oh,
little intermission that we're going to do, and it's just for a stretch. It's nothing I made, it's nothing I did tonight. I couldn't do any big deal thing because I was out today. So but we'll be fine. All right. So let me just
mhm.
say hi to everybody. Bila and Poppy, Jean, Gary, Kim. Kim, thank you as always for your wonderful moderating. And Matt Hunter from New Zealand. Jan Morgan, welcome, Jan. Jerome, I saw you were here early. Christopher Spavins and Wolf Heinel. Wolf. I don't even have a wolf sound. Jennifer, I wish I had a wolf sound for Devon Bledsoe. She sent me something today. I didn't upload it to Vaughn, but I might try because it was interesting about a big wave that hit one of those gigantic Antarctic cruise ships. People are just,
Oh.
yeah, they're so horrible.
Oh.
And I forgot to upload it. Hello, But the Truth and Raza, Nadia Groot, Earl. Okay, good. We're going to get started. We need to get started. So here we go. Guys, Jen, the one thing we did not do is decide to who is going to read the first article. And I need to just fix it a little bit so we can see it properly. All right. So why don't I start?
Who is going to read it?
I'll start.
You want to? Okay.
Yeah, I'm going to start because it's an easier one. And if my throat takes a crap, we got Jennifer's great voice. All right. So here we go. I just need to move a screen. And here we go. Did I get it? Did I get it right? All right. I got it right. So this is Yahoo News. And Jennifer sent this to me. And I thought, this is the perfect. Well, we had a flow this week, guys. We really had a flow. So here we go. What happened to autumn? Scientists point to climate change. You think? Okay. And there's Hamburg, New York, actually, not far from where I used to live. And this guy was, he was digging himself out there. That's where our governor's from. She's from Hamburg also. So regarded by millions of Americans as their favorite season, autumn, for many regions of the United States, has traditionally been marked by the gradual transition from hot, summer weather to frigid cold winter temperatures. But in recent years, fall seems to have all but disappeared. It has here, especially in the Northeast. Yay. And experts say climate change is partly to blame. All right. Partly to blame. So throughout October of this year, a time normally associated with crisp and, weather and changing leaves and lovely things that just happen in autumn, pumpkins and all. Many parts of the Northeast saw temperatures upwards of 70 Fahrenheit. And then seemingly overnight, the weather turned colder. It was more, Jennifer. It was like 2 weeks of hot that when it wasn't supposed to be. And I kept saying every day, I got to get out and clean up more. I got to get out and clean up more. It was unreal. It was that warm. So Spokane, Washington, the warmest October on record, was quickly followed in early November by the season's first freeze and snowfall. By the end of the third week in November, snow had fallen all over upstate New York, and Buffalo received a record-breaking 6 feet. Now, that was not in the city proper where my kid lives in the city, but it was more in the south towns. Like Hamburg got, I think, the most. And where I lived for 20 plus 22, whatever, how many years I lived right off the lake, they got hammered. And it was quite the thing. So we're seeing this weather whiplash here in the fall, where it could be so warm. It could have record warm temperatures, and then very quickly we could transition into that cold period. Judah Cohen, director of seasonal forecasting at the Atmospheric and Environmental Research, told Yahoo News. Experts such as Cohen say climate change is a factor. Weather is fluky. Fluky. I wonder if I have a sound for fluky, Jennifer. Weather is fluky.
I don't know what that would be.
I don't know. I guess the closest is there. All right. So weather's fluky, and it's impossible to ascribe most individual events to climate change, but climate change is creating the conditions, starting with a longer, hotter summer that makes fall-less years more likely. Last year, the Associated Press reported that the fall foliage season was delayed by warmer weather from Maine to Oregon, and in some places it was ruined altogether by unusually hot, dry summer that caused the leaves to die prematurely. Is that what it is? I'm always complaining about it. Summers are growing longer, Cohen said, September a lot of times acts more like August than what you traditionally consider a fall month. Summer is definitely encroaching on the fall season, and it's staying warm later for sure. Matthew Barlow, a professor of climate science at the University of Massachusetts Lowell, told Yahoo News. Well, we are actually looking in the Northeast for fall weather patterns, and you can see that you get summer patterns into the fall. One might expect that the typical fall weather would just be shifted until later in the year, as it would take longer for the temperatures to drop to these historically associated with winter. But there's another wrinkle attributed to climate change that explains why winter temperatures suddenly crash onto the country, plunging millions into winter-like conditions. Warmer Arctic temperatures in places like Alaska that send the polar vortex the polar vortex southward, right? The vortices, right? And yeah. So I would summarize that the whipsawing from weather extremes this fall as the summation of two competing factors: ambient warming due to increasing greenhouse gases and an increase in polar vortex stretching. That's pretty
key.
wild, right? Yeah,
Yeah,
the
that's the
stretch,
key.
guys. It's the stretch.
Yeah.
Oh, and so this is the same reason we are seeing more extreme winter weather, such as massive snowstorm that hit the South last January. So recent research finds the polar vortex is more frequently getting stretched out, which also brings that cold air south. The reason is uncertain, but it appears to be related to the dramatic loss of Arctic sea ice. Oh, yeah.
Oh,
Oh, yeah. According to a study led by Cohen that appeared in Science magazine last year. But while extreme weather gets all the attention, the same phenomena can happen in the fall, making a week in November feel more like January. Climate change, but for specifically the changes in the Arctic lead to more disruptions of the polar band, where the polar vortex kind of stretches, elongates like a rubber band, Cohen said. And we're definitely seeing an increase in those types of events in October through December. This is Baffin Bay in Greenland. Drones are unreal, aren't they, Jennifer? Oh my God. I think it's applicable to
Amazing.
what
So
they
beautiful.
are. I want one. But I'm not in Alaska, so what are we going to see? My trees. I think it's applicable to what happened this fall. So, because we've had these unusual polar vortex stretching events, he said. So, in October, there was this early cold weather snap and early snow. And I know places in the southeast were having the earliest freezes ever. Wow. So, for example, Baton Rouge, Louisiana, saw its earliest freeze in history in mid-October. The cold snap that we're seeing in November and extreme lake effects that we're seeing here in Western New York, that's also associated with the stretched polar vortex event, Cohen said. So, referring to that Buffalo, Southtown's snowstorm. In a complementary phenomenon, the jet stream, that band of warm air flowing west to east, is also being destabilized by climate change. The jet stream is powered by the temperature differential between the Arctic and other regions, and the Arctic is warming 4 times faster than the rest of the Earth. Wow. Every time I hear it, it just flips me out. As the difference in temperature
I know.
decreases, it does. It just does. A weakened jet stream is more frequently diverted southward, pulling the band of colder air farther south. So scientists caution that the research on winter weather now strikes more frequently in fall, and why isn't as robust as the research showing that global warming is causing hot weather to last longer into the year. There's the I-90 right there. I've driven it. It sucks. I'm sure you have too in Colorado, Jennifer, right?
I have.
Haven't you? Oh my gosh. Of
Well,
course you have.
it's in Wyoming. Yeah.
Oh, it's in
But I have.
Wyoming?
I've driven it across.
Yeah.
Yeah.
Ooh. Well, it's
Yeah.
not always fun. So anyway, it says it's certainly gotten cold here in a way that's felt sudden. But I'm not really aware of anybody who has run into those numbers to get at that variability piece of it, Barlow said. There isn't a consensus on that, I think, yet. Um, yet on whether there's an increased breakdown or stretching of the polar vortex or whether the jet stream is getting wavier, at least in the North Atlantic. But there definitely is some evidence of that. But I don't think there's a consensus. We'll see. The good news for people who want to take advantage of autumn's outdoor, well, this is Yahoo News, hon. And we have to realize that
Ugh,
they're trying to educate,
I know. I
yeah,
know they
yeah,
are.
not
They
us,
are.
not us. So anyway, the good news for people who want good news, right? You know, it's Yahoo. It's good news for people who want to take advantage of autumn's outdoor rituals is that because polar vortex stretching events are temporary, the warm weather can sometimes bounce back. In Rhode Island, for example, the
That's
first
the
freeze of the year in late October was followed by temperatures climbing back up into the 60s just in time for a trick or treat and also just in time to screw up the animals horribly and the birds and everything else that needs to be have a regular migratory pattern or hibernation pattern. What do you think, Jen?
yeah.
Yeah.
Yeah. Well, I think it's a good article. I think it's funny how they say we really don't know what exactly is causing this. And then they go on to say exactly what's causing it. And then they say there's no consensus, but then they say, exactly what's happening. So there is consensus in case anybody's
Ah,
wondering. The splitting of the polar vortex is a phenomenon that's been happening for well over a decade now due to
yep.
the fact the decrease of the differential between the Arctic and the temperate regions, just like they said, which causes the
Mm-hmm.
slowing of the jet stream, causes it to become wavier and loop down, down, down. Here, for example, in Colorado, we've just been coming out of a really cold snap. It was 3 degrees Fahrenheit here 2 mornings ago. And
Ooh,
that is an
burr.
example of the splitting of the polar vortex. And that's because where I live, it's on the Continental Divide, right? And it just comes straight down that mountain range when the when it's looping, right?
Wow.
And so it becomes and if it's down here, and by it I
Mm-hmm.
mean cold, and 3 degrees, that's cold, right? So
Yes.
if it's down here, it's not up there. That's the simple logic, you know? And if it's not up there, what does that mean? It means that it's hotter up there, and it means it's pulling hot air into the Arctic while it's pushing cold air down here. That's the splitting of the polar
And
vortex right
that's a
there.
lot what Elliot Jacobson has been talking about on his Twitter feed. And I didn't pull that up tonight because we just don't have enough time. But anybody want to check out Elliot, go ahead. He'll probably come on with us again because he's
Mhm.
trying to make his climate casino channel into something. So there cannot be too many voices. Absolutely not.
That's
And he
right.
yeah, and
That's
he
right.
loves to put his daily doom up on Twitter. So and it usually is a good one. But anyway, so Jen, you want to take over
Mhm.
and take over the next one?
Absolutely, guys. So we're going to
Okay.
jump into phys.org, and this is just out. A warmer Arctic Ocean leads to more snowfall further south, according to a new model. You might notice
Yeah.
a trend here. And look
Yeah.
at this great graphic, Sandy. Look at this great graphic. So you can see that the moisture laden air is pushing southwards from the Arctic. Interesting. And increasingly warm and ice free Arctic Ocean has in recent decades led to more moisture in higher latitudes. So there you go. A new model explains that water evaporating from the Arctic Ocean due to a warming climate is transported south and can lead to increased snowfall in northern Eurasia in late autumn and early winter. This information will allow for more accurate predictions of severe weather events. Rising air temperatures due to global warming melt glaciers and polar ice caps. Seemingly paradoxically, snow covers in areas of northern Eurasia has increased over the past decades. However, snow is a form of water. Global warming increases the quantity of moisture in the atmosphere and thus the quantity and likelihood of rain and snow. Understanding exactly where the moisture comes from, how it is produced, and how it is transported south is relevant for better predictions of extreme weather and the evolution of climate. Hokkaido University environment scientist Tomonori Sato and his team developed a new tagged moisture transport model that relies on the Japanese 55-year reanalysis dataset, a painstaking reanalysis of worldwide historical weather data over the past span of 55 years. How interesting, taking the same data and reanalyzing it in light of what you know
Wow.
now. That's so interesting.
Wow.
The
Wow. Wow.
group
Wow.
used this material to keep their model calibrated over much longer distances than hitherto possible, and were able to shed light onto the mechanism of the moisture transport, in particular over the vast landmass of Siberia. So that's pretty interesting to understand the details of moisture transport better. That's really important. A standard technique to analyze moisture transport is the tagged moisture transport model. This is a computer modeling technique that tracks where they precipitate due to the local climatic conditions. But the computer models become more and more inaccurate as the distance to the ocean increases. In particular, this makes quantitative predictions difficult. Thus, these methods have not been able to satisfyingly explain the snowfall in northern Eurasia. The results of the study, published in the Journal of NPJ Climate and Atmospheric Science, showed that water evaporation from the Arctic Ocean has increased over the past 4 decades, and that the biggest changes have occurred from the Barents Sea to the Kara Seas north of western Siberia, as well as over the Chukchi and eastern Siberian seas north of eastern Siberia between October and December. So they're targeting autumn, more moisture in autumn in those areas. At this time of year, the Arctic Ocean is still warm and the area is not covered by ice. And the area not covered by ice is still large. Importantly, this development coincides with the area where sea ice retreat has been strongest over the time frame of the study. In addition, the quantitative model shows that evaporation and snowfall are especially strong during certain weather events, such as cyclonic systems taking up unusually large quantities of moisture and transporting them south into Siberia, thus also highlighting, detailing, and specific mechanistic insights into the weather dynamics of the region. With the
Interesting.
Arctic being twice as sensitive to rapid warming than the global average, evaporation and subsequent changes to the hydrological cycle over northern Eurasia will become even more pronounced in the years to come. So we're just getting started, in other words. The researchers say that since snowfall often delays the downstream effects of the abnormal weather events that cause it, knowledge of the precursor signals stored as snow cover anomaly is expected to help improve seasonal predictions of abnormal weather, e.g., the potential for heat waves that enhance fire in boreal forests. The study therefore yields a key element to understanding the mechanism of this weather system as well as others that are influenced by it, and thus making better predictions of severe events that could do harm to people and infrastructure. So that was a little hard to understand. I see that it was put out by Hokkaido University, and that kind of makes sense because the English was a little rough. But the point of it is there's more moisture, there's more moisture in the system, and that moisture is coming from the Arctic into the temperate regions.
Yeah.
So more moisture pushing down on us.
It makes
So
sense.
there you go, Sandy, on that
It
one.
makes sense. It makes
Yeah,
sense.
indeed
And
it
then
does.
we're going to move over to another one that is, oops, wait a minute. Another one that is from the University of Washington that you found, Jen. And this one, the
Mhm.
strongest Arctic cyclone on record, led to surprising loss of sea ice. So now we are going a little from the weather, the jet stream of the weather, and we're going to talk about the sea ice. And I'm going to
Mhm.
pull it up. All right. November 29th, Hannah Hickey from the University of Washington. Warming climate is causing a decline in sea ice in the Arctic Ocean, where loss of sea ice has important ecological, economic, and climate impacts. On the top of this long term shift due to climate change are weather events that affect the sea from week to week. The strongest
Sea
Arctic
ice.
cyclone, the sea ice from week to week. The strongest Arctic cyclone ever observed poleward of 70 degrees north latitude struck in January 2022 northeast of Greenland. And I think I've lost our.
Mhm.
Wait a minute. Let me make sure we have our thing on. Okay. Sorry. Jennifer, can you read a little bit? I want to make sure I. Okay.
I would can I go ahead and get started over again
Yes.
because
Yes. Get started over
we're
again.
only a paragraph into it.
All
Okay,
right.
here we go, guys. I kinda wanted to do this one
Oh,
anyway.
good.
A warming
Yay!
climate is causing a decline in sea ice in the Arctic Ocean, where loss of sea ice has important ecological, economic, and climate impacts. On top of this long-term shift due to climate change are weather events that affect the sea ice from week to week. The strongest Arctic cyclone ever observed poleward of 70 degrees north latitude struck in January 2022. So, guys, just like 11 months ago. So, this is an analysis of something that happened 11 months ago, the biggest Arctic cyclone ever. And if you didn't hear about it, you're hearing about it now. So that was in January 2022, northeast of Greenland. A new analysis led by the University of Washington shows that while weather forecasts accurately predicted the storm, ice models seriously underestimated its impact on the region's sea ice. So now we're going to see what actually happened to the sea ice. This is the analysis. The
Okay.
study published in October, so it took them all that time to publish
Mm-hmm.
this study in the Journal of Geophysical Research Atmosphere suggests that existing models underestimate the impact of big waves on the ice flows in the Arctic Ocean. Quote, the loss of sea ice in 6 days was the biggest change we could find in the historical observations since 1979. And key thing about 1979 is that was when satellite observation began. So that's the beginning of our satellite history, right? So that since we've been watching it, this is the biggest change we have seen, period. And the area of ice loss was 30% greater than the previous record, said the lead author, Ed Blanchard Wigglesworth, a research assistant professor of atmospheric sciences at the UW. Quote, ice models did predict some loss, but only about half of what we saw, in the real world. Key. Accurate sea ice forecasts are important safety tools for the northern communities, mariners, and others operating in Arctic waters. The accuracy of forecasts in the Arctic Ocean also has broader effects. Quote, the skill of a weather forecast in the Arctic affects the skill of weather forecasts in other places, said Blanchard Ribblesworth. The January 2022 cyclone had the lowest pressure center estimated since satellite records began in 1979, above 70 degrees Fahrenheit of a typical winter storm. Climate change doesn't appear responsible for the cyclone. The researchers didn't find a trend in the strength of intense Arctic cyclones since 1979, and the sea ice area was close to the historical normal for that region before the storm hit. I don't know. We'll have to come back to that. I think climate change could have had a hand in it, but we just don't know yet. During the storm, record winds howled over the Arctic Ocean. The waves grew to 8 meters, which is 26 feet tall in open water, and remained surprisingly strong as they traveled through the sea ice. The ice heaved 2 meters, which is 6 feet, up and down near the edge of the pack, and NASA's ISIS-2 satellite showed that the waves reached as far as 100 kilometers, which is 60 miles, towards the center of the ice pack. So for basically 60 miles all around the edge of the ice pack, that ice was rocking and rolling by 6 feet up and down. 6 days after the storm struck, sea ice had thinned significantly in the affected waters north of Norway and Russia, in places losing more than half a meter of thickness. It was a monster storm, and the sea ice got pummeled. And the sea ice models didn't predict that loss, which suggests there are ways we could improve model physics, said second author Melinda Webster, research professor at University of Alaska Fairbanks. She begins a research position at UW Applied Physics Laboratory in the new year. Well, congratulations to you, Melinda. The new analysis shows that the atmospheric heat from the storm had a small effect, meaning some other mechanism was to blame for the sea ice loss. We can think about that. All that hot water getting churned up underneath it, rocking and rolling, right?
Yeah.
Possibly before the storm than models had estimated, and that the storm's wave broke up ice flows more forcefully than models predicted as they penetrated deep into the ice pack, or that waves had churned up deeper, warmer water and brought it into contact with sea ice, melting the ice from below. Exactly what we've just said, right, guys?
Yep.
So we see it. We see what's happening. The unexpected ice loss, despite an accurate storm forecast, suggests that this is an area where models could improve. The researchers hope to monitor future storms to pinpoint exactly what led to dramatic sea ice loss, potentially by placing sensors in the path of future approaching storm. Well, this storm doesn't appear to be linked to climate change, and I take exception with that. We just don't know how measured, just be coinky dinky, not related to climate change when climate change is wreaking havoc all over the world, right? We just don't know yet. We just don't know yet. So we can say right now, because we don't know, while this storm doesn't appear to be linked to climate change, the increase of open water as the ice melts is allowing for larger waves that are eroding Arctic coastlines. Those waves, researchers said, could also affect the remaining sea ice pack. Going into the future, this is something to keep in mind, that these extreme events might produce these episodes of huge sea ice loss. Blanchard Rigglesworth said, other co-authors are, there are a lot of co-authors, and it was funded by NASA and the U.S. Navy's Office of Naval Research and Schmidt Futures. So in any case, this was a big study that they've been doing all this whole last year since the strongest Arctic cyclone on record led to a surprising loss of sea ice. And guys, this isn't a surprise to any who watches the show regularly, because we actually did talk about this Arctic cyclone. I remember we mentioned it, and it seems that there's an Arctic cyclone up there right around January almost every year. And not only that, there's also rain at the North Pole right around January. So let's watch and see what happens this January. But these giant Arctic cyclones with low pressure are breaking and destroying the Arctic sea ice at a record pace. And that's a fact.
Can I ask the chat how the audio is? I think we're having a little choppy evening, but I want to make sure that everybody can hear everything.
Are
just
we?
give us I don't know what's going on. I changed our background. That's why to make sure I gave us more bandwidth. I don't know, what happens. I changed it. We have the brick wall background now. And I think it seemed everybody's saying it's good. Gary, it's good. Audio's fine. All right, great. Because I heard it breaking up, but I'm happy. And hey, you guys like the brick? You like the brick wall? Good.
Wall's good. I like the brick wall.
Yeah,
it takes up less bandwidth. I do notice that there's a pretty big lag when I look at the eCam. There's a pretty big lag with me.
Yeah, well,
so
there's always a lag.
No, we don't.
All right. So we are going to move on, and Jennifer is going to talk about Pita Kata. And Peter is all our friend, but Peter, Peter will give us stuff. This was his Facebook post. Jennifer, why don't you, tell me what you want me to do with this, and I'll just follow your lead. How's that?
All right. Well, let me go ahead and see if I can make this picture here that he posted. Study reveals feedback link between methane and climate change several times more powerful than is earlier assumed. Yeah, several times more powerful than early assumed. I really hate to be right sometimes. It's sort of a bummer. I really wish I wasn't. But I've been following methane myself for well over a decade. And I've always felt that methane was going to be a really big deal in the future. So you can go into this, Sandy. We'll put this link. He does reference something in Nature about this. Let me see what happens when I click on this and see if it will come up.
Is it big enough for you to see on our screen?
Okay, this is I'm not looking at what you're showing. I should check and see. So here, no, I'm not looking at that. Sorry. Impact of interannual and multi-decadal trends on methane climate feedback and sensitivity. So embedded, the point of it is embedded within this post, that Facebook post, there is an academic article, looks like Chinese and European, and I'm not going to go into it because it's really academic, but it's all about methane, and it's all about how methane is much more potent and the climate sensitivity is much greater than earlier understood. So encourage all of you guys to check out Peter Carter's post when Sandy puts it in the show notes.
I will.
Right?
And
he did another post as well, Sandy.
Yeah, he did. And you're going to talk about that. But what I wanted to show really quickly was I wanted to stick in the Polarstern research, because what Peter's Peter references he's going to reference some of the research that finally, is coming out of the Polarstern. And this figure here is the year-round trace gas measurements in the Central Arctic during the Mosaic expedition, which we lovingly covered because we really actually we loved it. And so there are different collection mechanisms that the boat had done, different boxes for different kinds of see the CO2, the Swiss container, they call it the CO2, the CH4, the CO, the O3, the S2, so that they could use the raw data sets pre-post. You can see how it goes through local contamination screening procedures, and it goes up to final merged data sets. But this is their experimental workflow. And they took the trace gas ambient air measurements discussed in this paper, which I'm not going to show you the whole paper, but it's in Nature, were performed on sea ice from a 10 a meter tower at Met City, and on board Polarstern in the 3 different sea container laboratories referred to as the atmospheric radiation measurement arm in blue. So the University of Colorado, yay, Colorado, in yellow, and Swiss in red.
Yay,
containers.
Colorado!
Yeah, that's right. It's always nice. It's always nice. They do such great work there. Note that instruments located in the CU container, so you can go back and see this, and I'll have all these links in there, were connected to sampling inlets on the bow crane. Measurements included nitrous oxide, ozone, carbon monoxide, carbon dioxide, CO2, the big one. And methane, CH4, the other big one. Dimethyl sulfide, DMS, selected volatile organic compounds, VOCs, gaseous elemental mercury, and sulfur dioxide. And the post-cruise analysis of discrete whole air samples collected in background air upwind from research activities was performed at the NOAA back home after the boat came in. And they say in addition to continuous measurements, discrete samples were also occasionally collected for independent DMS analysis in the CU container. So there's that one. In case of redundant measurements, example CO2, the cross-evaluated individual data sets were used to generate a merged data set in order to limit gaps in time. So the whole link will be in there. I didn't want to do the whole Nature article, obviously. We just wanted to show you part of how some of the research came out and where it came from, and how Peter will probably benefit. So that's why I sandwiched him in between his 2 Facebook posts. So here we go. Here is the next one. Jennifer, take it away.
All right. Okay. So this looks like, not really actually sure. It looks like, as we said last week, 89.8% of the world, or basically 90% of the world's energy, is from CO2 emitted from combustion, and that is a combination of coal, gas, and oil. And that's really the point of it, to show the volumes of the coal, gas, and oil. And then smaller is biofuels, smaller still is nuclear, and smaller still is other. And other includes like wind, solar, and all that stuff. So it's just kind of a wake up and smell the coffee that 90% of our energy at this point comes from coal, gas, and oil. That's the point of those graphs there, Sandy.
It is. See, somebody says sad graphic.
Just a little reminders to where we're at.
I like this comment, sad graphic to see.
It is a sad graphic to see, right?
Yeah, and this person said, when we realize it does not account for the decomposition and release of CO2 and CH4 from northern latitude soils as they warm, nor does it account for the weakening of carbon sinks as the Amazon is shredded and the plankton of the oceans are weakened by pH dropping. So there's so much more to the story, so much more to the picture. All right.
Yeah.
So as we move along, we are keeping very good time
So much more
tonight,
to
I
the
do
picture.
believe.
And it's sad. It is sad. Oh, yeah.
All right. So we're going to move on, guys. Guess where we're going? We are going to one of our favorites, our favorite people,
Where?
and we are going to the Barents Observer. Yes, we are. And we're going to go a little bit into this article,
Okay.
which, yeah, and we could tag team it if you want. I thought it was really a good one to segue to from uh, weather events necessarily to a little bit of. We'll talk about organisms and plankton and what's happening with these little cute guys like like this, these little guys. They're just, they are very important. They are very, very important.
Oh,
Yes, they are. So let's get
yeah.
started. The Arctic Ocean is changing towards a warmer, ice free state in the summer. The warm Atlantic water continuously carries plankton organisms from south to north. Boreal species usually perish in the cold, dark Arctic. Oh my God, Arctic. The Arctic. I sound like Mork. The Arctic Ocean tonight. That may change as climate warms, sea ice shrinks, and the primary production season lengthens. So you're seeing here these graphical distribution areas for the Arctic: Calanus, glacialis, and the North Atlantic Sea, Fin marcius. The darker color indicates the species' core distribution area. And it shows the different body sizes in this picture. So these are little copepods of the genus Calanus dominant, and they dominate the zooplankton biomass in the North Atlantic and in the Arctic Ocean. They constitute the key link between primary producers, microscopic algae, and higher trophic levels, securing essential fatty acids such as omega 3 from algae to be efficiently channeled to fish, marine mammals, and seabirds. 3 Calanus species exist in the European Arctic. 2 of them, the Arctic Sea glacialis and the North Atlantic Sea Fin marcius, are frequently used as climate indicator species due to their distinct biogeographical distribution ranges. The larger C. glacialis is found everywhere in the Arctic, whereas the C. fin marcius resides in the Norwegian Sea and is restricted to areas influenced by warm Atlantic water. Thus, it is considered to be an Atlantic expatriate. That's cute. It's an Atlantic expatriate, huh? But yeah,
Yeah.
I know, right?
It's an
Body
expat.
size. It's an expat, and this is it's our little expat guy today. Yeah, this guy, they're little expats. Look. All right, so that's the body size is commonly used to distinguish between these two very similar species. However, recent DNA analysis has revealed that C. glacialis can actually be much smaller than previously assumed, and that there is a large overlap in the body size with C. fin marcius. So, being large is an advantage in environments with seasonal resource limitations, such as the Arctic Ocean. It allows organisms to store larger energy reserves, enabling them to survive periods with low food abundance and to spawn early, fueling reproduction with internal resources before the fresh algal food is available. So early spawning ensures that the offspring can take full advantage of the short algal spring bloom, but it takes time to grow large in cold temperatures. So depending on food availability, it could take 1 to 3 years for Calanus to reach adulthood. However, with higher temperatures and earlier sea ice retreat, resulting in longer periods of algal production, Arctic zooplankton may be able to accelerate their development, reduce their generation times, and hence push the higher sea temperatures. Wow. And push the population towards smaller individuals. At the same time, higher sea temperatures and a longer open water productive season will make the high Arctic more suitable for boreal species. This leaves us with a conundrum. How do we interpret an increase in abundance of smaller Calanus? Does it reflect a change in species composition, i.e., northward shift of the small boreal and fin marchius, or is the Arctic species becoming smaller? Now, these questions can only be resolved if we monitor or we include molecular identification in long term zooplankton monitoring, since genetics is the only method to ensure correct species identification. We may underestimate 20 to 30% of the sea glacialis populations in some areas if we continue to use only body size for species identification. So see how they're doing the sampling in these consolidated areas in that graphic, in that picture?
Mm.
Wow. A lot of work for those tiny little guys. So I'm just going to go down to the seasonal bottlenecks because that just shows that they from the Arctic, they're still a rarity. However, recent extensive freeze in drift expeditions by R.V. Lance, and that was in 215, and the Polarstern, the Mosaic, who we love, combined with seasonal cruises by R.V. Kronprinz Haken, Nason Legacy, and year-round studies in Svalbard fjords, have improved our understanding of how Calanus populations deal with strong seasonality in the Arctic. And you see, it's just so important, Jen, isn't it? So important to know what these little tiny things, they are so important for us to understand what's going to happen to us. Basically, because they're like these little building blocks of
absolutely. Well, it's
food.
the base of food.
Yep.
Yeah.
So basically, we'll just go here.
It's the base of the food chain.
Base
right
of the
there.
food chain. Yep.
That's
And they're
the base
showing
of
right
the
here
food
this
chain.
bottleneck, and past, present, near future, distant future. I like the way they put the little black skeleton, the skull with the crossbones. Oh boy. So they're saying conceptual understanding of changes in the Calanus community and body size structure in the Arctic Ocean with climate change. In the present and near future scenarios, both Arctic and boreal species thrive and do better in warmer climate with less sea ice and an extended algal production. However, the Calanus population size structure changes due to increased survival of small boreal species combined with a decrease in body size in Arctic species. How far this can be sustained with increasing warming is currently uncertain. Ultimately, it may lead to extinction of present Arctic specials, the specialists. Oh my gosh. So I'm not going to go through the whole thing. I just want to just say that they go through and they talk about their is it a dead end or an opportunity, really? They say their studies demonstrate that closely related copepod species with slightly different life strategies and environmental preferences coexist in the large parts of the Arctic. But this coexistence of several species within the same copepod genus presumably makes high latitude zooplankton communities more resilient. So that's there's good news. It's burgeoning research. So they say that the main ecological concern in a future warmer Arctic with considerable Atlantification of the zooplankton community is the replacement of large, fat copepods with smaller and less nutritious ones. So bottom line, through generation time, they're saying it's increased capacity to complete life cycles in the high north will likely increase the overall secondary production and thus largely compensate for reduced nutritious quantity per individual copepod, which so many animals rely on. Right? Yes. So that is that one. The link will be in there. I thought it was interesting
Yeah,
that the
absolutely.
Barron's Observer did this one. You know? Yeah. So let's take a little.
Yeah, well,
Jennifer, why don't we?
populations of small animals are changing.
They are. They are. But in the interest of small animals, guys, we have a cute little, very short intermission before we come back with a couple more heavy hitters. And let's take a break and watch this. Now, just understand this is kind of marketed towards the little ones. Enjoy.
The Arctic is a harsh environment for any organism to survive. It's bitterly cold, there's super strong winds, and the amount of daylight changes drastically from season to season. Yet some organisms have some pretty cool adaptations that allow them to live in the Arctic for all or most of the year. Today, we're going to take a look at one of the most famous and fierce Arctic animals of all, polar bears. A worksheet relating to this video can be found in the link in the description. You may want to download it now and complete it as you watch. These amazing animals are perfectly suited to the icy Arctic. To withstand the constant freezing temperatures, polar bears have 2 layers of transparent fur. They have a soft and thick undercoat which keeps the bears warm, and an upper layer of guard hairs which are hollow and help to keep water away from the insulating undercoat. Polar bears are white in colour, which is a great adaptation for sneaking up on unsuspecting seals. But their fur is actually transparent and hollow. They appear white because the hollow air spaces in each hair scatters and reflects light of all colours. As no colour within the visible light spectrum is absorbed, we see polar bears as white. Beneath the guard hairs and undercoat is a layer of black skin. Sunlight passes through the transparent hairs and reaches the black skin, which is good at absorbing heat, another way polar bears keep warm. And if hollow, transparent hairs and black skin weren't enough to keep the polar bears warm, below the skin is a thick layer of fat called blubber, which provides further insulation. Polar bears have very large paws with long, sharp claws. The claws help it to catch and tear flesh from its prey. Powerful jaws and sharp teeth help out here too. And the large surface area of the paws also make polar bears great swimmers. Polar bears are top predators. They are the largest of all animals, reaching heights of up to 9 feet and weighing close to 1 ton. Their enormous size enables them to prey on other large animals, including seals, walruses, and even whales. Polar bears depend on floating sea ice to move from place to place and catch prey. Sadly, human-induced climate change is causing our planet to get warmer, and sea ice is melting faster than ever before. Although polar bears are not endangered at the moment, their numbers are declining. Let's all act now to save our planet and the magnificent polar bear. Thanks for learning!
Oh, that was so cute. Remember, guys, this was the kid. That was for
That was
kids.
so cute.
Yeah, we thought we would give you
That
a
was
little
cute.
treat. Yeah, it was cute. It was cute. So, where we are now. All right, Jennifer. Why we can go a couple of different ways.
Mhm.
we have some interesting stuff that is, well, right now, actually, it is about, we could show you what the Department of Defense is doing, right? Because we said this was an Arctic show. We're not going to read you the whole thing, but we're going to show you. We also then have an article, which I think we're going to end with two articles. The Arctic Carbon Conveyor Belt, Jen. I think we should do that one. And then the
Mm-hmm.
European
do too.
Reporter. Yeah. Arctic, all the more important in the wake of Russia's invasion in Ukraine. Conference told. So there's a lot going on. And do you want to take this one, Jen? The Arctic carbon conveyor belt?
Absolutely.
All right. And then I'll just show you guys what
Carbon,
the Department of Defense is doing.
absolutely.
All right. All right. Here we go.
Woo! All right.
There it is.
So this just out, guys, from viz.org. Arctic carbon conveyor belt discovered. Every year, the cross-shelf transport of carbon-rich particles from the Barents and Kara Seas could bind up to 3.6 million metric tons of CO2 in the Arctic deep sea for millennia. In this region alone, a previously unknown transport route uses the biological carbon pump in ocean currents to absorb atmospheric CO2 on the scale of Iceland's total annual emissions. As researchers in Alfred Wegener Institute and partner institutes report in the current issue of the journal Nature Geoscience. Compared to other oceans, the biological productivity of the central Arctic Ocean is limited since sunlight is often in short supply either due to the polar night or sea ice cover, and the availability of nutrient sources are scarce. Consequently, microalgae, phytoplankton in the upper water layers have access to less energy than their counterparts in the other waters. Because of this, the surprise was great when on the expedition Arctic 2018 in August and September of 2018, on board the Russian research vessel Akademik Troishinukov, large quantities of particulate carbon, e.g. stored in plant remains, were discovered in the Nansen Basin of the Central Arctic. Subsequent analysis revealed a body of water with large amounts of particulate carbon to depths of up to 2 kilometers, composed of bottom water from the Barents Sea. The latter is produced when sea ice forms in winter and cold from the shallow coastal shelf down the continental slope and into the deep Arctic basin. Quote, based on our measurements, we calculated that through this water mass transport, more than 2,000 metric tons of carbon flow into the Arctic deep sea per day, the equivalent of 8,500 metric tons of atmospheric CO2. Extrapolated to the total annual amount revealed, even 13.6 million metric tons of CO2, which is on the same scale as Iceland's total annual emissions, explains Dr. Andreas Roge, the first author of Nature Geoscience's study and an oceanographer at Alfred Wegener Institute, Helmholtz Center for Polar and Marine Research. This plume of carbon-rich water spans from the Barents and Kara Sea shelf to roughly 1,000 kilometers into. In light of this newly discovered mechanism, the Barents Sea, already known to be the most productive marginal sea in the Arctic, would appear to effectively remove roughly 30% more carbon from the atmosphere than previously believed. Moreover, The model-based simulations determined that the outflow manifests in seasonal pulses, since in the Arctic coastal seas, the absorption of CO2 by phytoplankton only takes place in the summer. Understanding transport and transformation processes within the carbon cycle is essential to creating global carbon dioxide budgets and therefore also projections for global warming. On the ocean surface, single-celled algae absorb CO2 from the atmosphere and sink towards the deep sea when aged out. Once carbon bound in this matter reaches the deep water, it stays there until overturning currents bring the water back up to the ocean surface, which takes several thousand years in the Arctic. And if the carbon is deposited in deep sea sediments, it can even be trapped there for millions of years, as only volcanic activity can release it. This process, also known as the biological carbon pump, can remove carbon from the atmosphere for long periods of time and represents a vital sink in our planet's carbon cycle. The process also represents a food source for the local deep sea fauna like sea stars and sponges and worms. What percentage of carbon is actually absorbed by the ecosystem is something only further research can tell us. The polar shelf seas harbor other largely unexplored regions in which bottom water is formed and flows into the deep sea. As such, it can be assumed that the global influence of this mechanism as the carbon sink is actually much greater. Quote, however, due for less bottom water is formed. At the same time, more light and nutrients are available for phytoplankton, allowing more CO2 to be bound. Accordingly, it's currently impossible to predict how this carbon sink will develop, and the identification of potential tipping points urgently calls for additional research, says Andreas Roge.
It's always
And
additional
that
research.
is that. So that's like a new thing. It's a
Yep.
new thing. It's a new thing. They're socking
And
away more carbon in the deep Arctic than previously supposed.
yeah, and we've covered a
So there you
lot.
go.
Yeah,
It's been a
we've
very interesting show, Sandy.
and what
We
I just
have.
wanted to show you guys was just to kind of bring you down. I'm gonna I mean, it has to happen, but I think the toilet flush tonight, we're gonna give it to the Department of Energy without even knowing what it says. There, that's for Earl. All right. I'm just going to go quickly. I want you guys to know, that there's a lot of angling going on by all the countries, you know, all of them. All right. So they have this executive summary, and this just came out. This came out in October, and it's the Department of Energy. And what they are saying is basically that, well, we have security interests. We have a lot of interests, and their mission. This is their mission to ensure America's security and prosperity by addressing its energy, environmental, and nuclear challenges through transformative science and technology solutions. Notice the word solution. The DOE is committed to equitable outcomes.
Mhm.
So they catalyze this timely material and efficient transformation of the nation's energy system and secures U.S. leadership in energy technology. So we are rah rah tonight on the Department of Energy, and this was just the executive summary, guys. And they had, I mean, it's not that long, and really, seriously, it's a good read if you want to know what all these different arms of governments are doing. It's not just the United States government, of course, but we're in the United States, so we're talking about it. And they're talking about their strategic goals, and there's quite a few of them. So we're not going to go on with this, but I just wanted you to know that this does exist and it's out there. And You guys should be educated and understand there are many, many people jockeying and vying for the Arctic now.
Mm-hmm.
And
Mm-hmm.
then,
Indeed. Well, what an interesting show, Sandy. We've been all over the place.
yeah, we had one more, but I don't know if you wanted to do this one. The how the Arctic. This is just really talking about the importance to all the countries that even countries that don't and Russia has the largest amount of beach land. They have the largest amount of Arctic, and everybody wants to manage it together. And this is an EU. They had an EU conference, and Arctic strategy is a key tool. So we're just going to leave this one in, unless Jennifer, you're interested in doing a little of it. What do you think?
Not, no, not really.
Okay.
No.
Well, then everybody, it's
I don't
there.
have it pulled up right now.
It's there. Don't worry about it. It's there, and you guys can peruse it. It will be in the show notes. And Jennifer, there was so much more, but we couldn't possibly do it all. We would be here for 3 hours.
No, we have to contain ourselves.
Yeah, we have to contain ourselves. So let's see what's going on in the chat. Anybody have any questions? At least we got one flush in. Well, I think that everybody in the chat is having their they're having their own little thing tonight. So Jen, would you like to wrap up our show for tonight?
Yeah. I mean, for this Earth, and it's not. I mean, to say that the Arctic is the cause of a lot of things is true, and we've really focused in on the Arctic today and how, for example, a warmer Arctic Ocean leads to more snowfall here further south, right? And this is affecting us right now. We've been studying about the jet stream and how the Arctic affects the jet stream, affects the weather further south, and it's all connected. And the Arctic is changing very, very quickly, and it's going to continue to change very, very quickly. I think one of the most interesting things, Sandy, was that Arctic cyclone. The strongest Arctic cyclone in recorded history led to surprising loss of sea ice. And that really just shows how that ice can get ripped up by a single event, right? So just like hurricanes are getting stronger out here, and, like Hurricane Ian and stuff like that, the cyclones in the Arctic are also getting stronger. It's not a coincidence. So I would say, fasten your seatbelts, buckle up, Buttercup. Isn't that what they say, Sandy? Buckle up, Buttercup.
Buckle up, Buttercup.
Hang on, it's going to be a bumpy ride.
Buckle up, Buttercups out there. Yep. We are definitely actually
right.
We should
buckle
be
up, Buttercup.
up, but we should be buckled up because we're not just beginning to be in it. We are in it, and we are seeing it, and we have all of you to see it with us. Jim McHenry, Dan Marceau, and I saw Nicholas Miller from Mexico, and Artificial Morphous Man. And Kim, thank you. Truly a gas root. And I want to say thank you, everybody, for the donations. They really help. You guys have been just wonderful. And I mailed out some more coffee cups. And I did send an email. So if you haven't gotten your coffee cup, send me your address so I can pack them up and send out some more.
All right. That's great, Sandy. Well, it's been a terrific show. Thank you so much. And it's been a great collaboration, good focus on the Arctic.
Yeah, a little technical snafus tonight, but everybody was happy, and that's what I'm concerned about. You're all happy out there? Thank you. Jennifer, I love you. You know that. And we have more to come. More to come.
Love you
Uh,
too.
yeah, more to come. And see you on Sunday. I have a guest, an interesting guest. You'll hear all about him on Sunday. All right? Good night, guys. We love you.
Good night.
Yes.